Dear student, this is Shodhari. In this video, we know about the polygons and types of polygon in detail. Okay. What is a polygon? Definition. It's made up of two words. First one is a poly, which means many, and the second is gons, which means sides. Means whatever the object we are creating, it should be in a closed loop. Okay. This is a polygon. Why we are calling that? It using a vertex and making edges. Using a number of these vertex and edges making a polygon. It should be a closed loop. Okay, polygon are made with two components. First is vertex and second one is your what we have to say? It's a side vertex and the edges of a given we can make a polygon. Okay, it is another type you have to say. These are shapes made of straight lines and they represent in computer graphics to make a different objects and we can create a image. Okay, so a polygon is fundamental building blocks to create a 3D models or a 2D models. 3D means it's in a 3 dimension, x, y and z coordinates. We can make a multiple angle. 2D it's a two-way, either x direction or y coordinates. We can say the object. Okay, so examples are for the polygon is a triangle, quadrilateral, pentagon and hexagon are all some examples of a polygon. Okay, now next is types of polygon. In types we can say means we are using a simple and complex. Means how we have to define a given polygon is a simple and complex. Simple means the sides are straight line, a segment that connect to form a single interior space and do not intersect. Means whatever the we taken the polygon, it should be in it's made a direct one. It simply used a lines and making a polygon. It should be a closed loop. These lines are not intersecting each other. What is a complex? In complex, these lines are intersecting and making as a polygon. This is also a polygon. This is the difference between simple and a complex. In simple, they are not intersecting each other. The straight lines are forming and line are not intersecting each other. Okay, so in complex they are intersecting. Self-intersecting sides meaning the lines cross or overlap forming a multi-loops or a twist. Okay, this is called a complex polygon. Next is a convex. What is a convex? Here the polygon which are interior angle is less than 180. Okay, so those polygons are called a convex. Another point is if taken the pixels make a line, the line should be formed in within the polygon. That is called a convex. Okay, what is a concave? Concave means whatever the polygon you are taken, the pixel should be inside the polygon and want to draw a line, the line should be the part of line lies outside the polygon. This is a concave. Okay, the one of the angle is greater than 180 degree. Example are a common a star shape. This is one is a concave. Okay, one of the angle is greater than 180 and the when we want to draw line with using a pixels, it will a part of line cross the means it appear on the outside the polygon. I hope this is clear. This is the types of a polygon. Now how we have to determine the taken pixel is within the polygon or outside the polygon. How we have to find out? For this in computer graphics there are two methods are given. First one is even odd method or it is also known as a inside outside test. And second is non-zero winding number, or you can say winding number method. Okay, we will see one by one the methods. Now we will know about the definition of polygon. Next, what the types of a polygon. Now we will see how the pixels are identifying whether it is inside the polygon, outside the polygon. Why it is important? Why we have to need to learn these methods? Because when we want to fill these polygons, then we must know about the taken pixel is inside the polygon or outside. If inside, then only you have to fill in this polygon, right? For that purpose, we are using these two methods. Okay, we'll continue with this test. It's a even odd test. What is a even odd test? It is checking the taken pixel or a point is inside the polygon or outside the polygon. What is the procedure? How we have to check out the given pixel is inside or outside? Okay. So first point is why it is important we discuss for filling the color to the polygon, right? So what is the procedure? How we have to do this test? First take a pixel, okay, then draw a straight line from where a point to cross the polygon boundary. For example, here this is your given polygon. We want to start a polygon with here. Means this is a pixel we are taken. Now with the help of this pixel, we draw a line to cross the boundary. Means if pixel is here, then we draw a line. Now count how many times this pixel's line is intersecting to the given polygon boundary. Its count is odd. It is a one time it is intersecting, right? Both pixels are intersecting a one time, means it is a inside the polygon. What if a pixel is here? Now we draw a line to cross the polygon boundary. Now count how many intersections are there. There are two intersection points. So means it's a even number. So it's a polygon is out of the polygon. Now what we have to know about now, what is the concept here? If even number of intersection happen, then the pixel is outside the polygon. If the odd number of, example 1, 3, 5, 7, so the pixel is inside the polygon. A simple method is there, a procedure is also simple. First point, you have to take the pixel. With that pixel, draw a straight line to cross the polygon boundary. Now count the intersected points. If intersected count is even, then the point or a pixel is outside the polygon. Else a point is inside the polygon. This is for even odd test, simple one. Okay. This is a figure of a polygon given. Now we want to check point A is inside the polygon or outside the polygon. Okay, here A is given. Now they draw a line. Now count the intersection is 1, means that A is inside the polygon. Now come to the B point. Okay, B is draw a line. How many times it intersecting? 3, right? It's a odd number, right? Again odd number we get it. So it's also B also inside the polygon. Now look at the C. C is crossing a 2, right? So 2 is even number, means C pixel is outside the polygon. This is for a inside outside test or a even odd test. I hope this concept is clear to everyone. Now the second method is to find out the given pixel is inside outside, that is the non-zero winding number. Okay, so in this method we are taking the polygon with the direction, they give the path direction, that is called a wind. So it will check whether in a clockwise or a counterclockwise. So how, with the help of figure we will see this. Okay, here point P is given, right? So with the P we want to find out that pixel is inside or outside the polygon. Okay, here is a P, right? So we have to do? First, with the help of that pixel, we draw a straight line. Now, see, count the edges, how the edges is going, to left to right or right to left. Taking out the help of we are mentioning the value as a positive and negative ones. So, in this example, we are taking from pixel to left to right or right to left, we are assigning a -1 +1, right? With the help of that direction, they are opposite to each other, then taking a +1 -1. So what is the wn number here? The wn number is equals to 0. Means if the wn number is 0, then the pixel is outside the window. If we getting a w of n number is a non-zero, okay, then non-zero means what? Maybe it is a positive one or positive, it's not equals to 1 or not equals to 0, means it having a value of something, either a positive or a negative values. Okay, either +1 -1 +2 -2, but it should be a number. Then that case it's a pixel is taken is inside the window. This is a formal, means we are in general I explained here. What is a procedure? A step by step we will see the procedures. Okay. Here I am taking this pixel to draw a line with the crossing the boundary of a polygon. Now count is wn is a 1 in the +1 or a -1, right? If you want to take a clockwise as a +1, then a counterclockwise -1. If we are taking a clockwise as a -1, then counterclockwise or anti-clockwise is +1. Remember this, okay? Now, procedure we will see. First point is, or first step is to initialize a winding number. That is a wn number equals to 0. Okay. We assuming that it's a 0 means outside. If not, then we with the help of that pixel draw a line. Okay, from the point in the question, draw an imaginary line extending in any direction towards the infinity. Okay, so vertices will, in this we not pass through any polygon vertices. Okay, count the intersection with the direction. Intersection, we counting the intersection points with the direction, either in a clockwise or in maybe a counterclockwise. Traverse the polygon's edges and for each edge that intersect the line. Okay, if the edge crosses the line in a counterclockwise direction, okay, for example from right to left as viewed along with the line, okay, then we are adding a wn number equals to 1. If the edge crosses the line in a clockwise direction from left to right as viewed along the array or a line, subtract from the winding number. Okay, wn number is -1. So what is the final winding number is non-zero. If final winding number is non-zero, then the point is considered as a inside, else it is a outside the window or sorry, a polygon. I hope this is clear to everyone, because here we are calculating the winding number with the help of a direction path. Okay, so for that we are to take the, if we want to take as a clockwise as a +1, then we